Hello and welcome to R&D Mathematics. Last video we actually talked about the standard form of a quadratic function and we briefly discussed that. So let me quickly recall you. Standard form is f of x equal a times x minus h squared plus k, and these numbers are special depending on a. If a is positive, it opens up and it can be in any quadrant, right? I'm just choosing first quadrant. Hk is the vertex and the axis of symmetry x equal h, and we saw those things briefly. Now today we are actually trying to graph quadratic function in standard form. Assuming that's given in standard form, we are going to graph it. Now let's see an example and understand the steps. First example, let's say we have the quadratic function f of x, and let's assume it's given in this form, x minus 3 squared minus 1. So step one is actually to identify a. A is 1 in this case, which is positive, so opens up. So we make a note, it opens up. And then step number 2 is vertex. Vertex is h comma k. H is 3. See h right here 3, not negative 3. That's a place where people might make mistakes. And k, here we have plus k. Because of that, k is actually negative 1. So the next step, well, you can start roughly putting putting them into action. So 3 comma negative 1, 1, 2, 3, 1, negative 1. So right here 3 comma negative 1, and because my graph opens up, I'm going to know what? I'm going to know it's going to hit my x-axis at 2 places. Because of that, my next step is finding x-intercepts. Now, just assume, just for the sake, argument's sake, assume what if it downwards. In that case, actually, you will not have x-intercept, right? We will see some examples like that. But anyway, this is going to have some x-intercepts. How do we find x-intercepts? Can you guys remember? Well, it's pretty universal way. In order to find x-intercept, you have to make y equals 0, because wherever it's going to hit, those places are y values are 0, right? So y value means fx value. So 0 equals x minus 3 squared minus 1. Well, what we can do is, we can use the perfect root system, square root method. X minus 3 squared is going to be equal to 1. So x minus 3 is going to be, when I take square root of both sides, it's going to be plus or minus 1. So we have two solutions, x minus 3 equals 1 and x minus 3 equal negative 1. From first one I get x equal 4, and the second one I get x equal 2. So my x-intercepts are actual x-intercept are 4 comma 0 and 2 comma 0, which makes sense. See here 2 comma 0, and it looks like 2 comma 0, and right here 4 comma 0. And now we are almost done, but one more step, because it's going to hit my y-axis somewhere. So the last step is actually finding y-intercept. So for y-intercept, you put x equals 0, and when you put x equals 0 right here, f of 0, y-intercept is x, y value of y-intercept is x of f of 0. So when I put 0 there, 0 minus 3, so 0 minus 3 squared minus 1, and 9 minus 1, which is 8. So my actual y-intercept is 0 comma 8. So it makes sense. See, somewhere here it's 0 comma 8, and we are done. That's how you graph it. And let's see few more examples. How about this next example? F of x. Well, let me go to the previous one, and the axis of symmetry is, it's pretty simple. It's obvious from the equation x equal 3. Okay. Now the next example, f of x equal negative 2 x minus 1 squared minus 3. I really like if you guys pause the video and try it for yourself. Okay, assuming you have tried step number 1, a equal -2, which is negative because of that open downward. We know that much. And vertex h comma k, and the h value is 1, k is -3. And now you can start putting it. So 1 comma -3, 1 somewhere here, -3, 1, 2, 3. So somewhere, 1, 2, 3, somewhere here. And it goes like this, right? 1 comma -3. And x-intercept none. X-intercept none because it looks like it's not going to hit the graph, but to be sure we'll verify it. So x-intercept, we make y equals 0 or f of x equals 0, and let's see what's going to happen actually if we try to solve this equation. -2 times x minus 1 squared minus 3. So let me add 3 to both sides. I get -2 x minus 1 squared. And now let me divide by -2. So I get -3 over 2 equals x minus 1 squared. Now this is weird, right? Why? Can you see that? Because see, right hand side is a square. It will be always positive. Or the minimum value, it may be 0, but it will be positive. See? And left hand side is negative, so it will never happen. So none. That is correct. And the y-intercept, is it going to hit y-axis? Yes, of course. Any parabola will hit y-axis. Remember that any parabola will definitely hit y-axis. Unless we restrict the domain, it is going to hit y-axis. So right here, this place. Let's check that. So y-intercept, and how do you find it? Making x equal to 0. So from here, f of 0, that means the y value of y-intercept when I make x equal to 0, 0 minus 1 squared minus 3. So minus 1 squared is just 1. So -2 into 1, -2 minus 3, -5. So actual y-intercept is 0, comma -5, which makes sense. It looks like that. So here 0, comma -5. And the axis of symmetry is pretty easy. X equal 1 just from looking at this equation. And basically we have drawn it, right? And yeah, I think that's enough example because that's the technique. Also, not just there's another thing too. Well, I think that will fit in another video, but let me make a bridge between this video and next. Probably not next, the one after next. Maybe, let's see. But anyway, the point that I like to make, look at this one. Let's try to simplify this. So -2 x minus 1 squared minus 3. So if I simplify this, -2 x minus 1 squared x squared minus 2x plus 1 minus 3. So -2x squared plus 4x minus 2 minus 3. So -2x squared plus 4x minus 5. What if the function, see this function right here and this function right here are the same? If it is given in this form, yes, you know how to do it using all these theories. It's pretty easy. But what if it is given in this form? Well, that's what we are going to address in detail in my next video, and after that another video, because this is general form. So first, in our next video, we'll address general form. But there is another way. If you are clever enough, if you know some techniques, I think we did those techniques known as completing square. Using that technique, we can convert this guy into this and use the standard form, this one, because this part is pretty easy. So in our next video, we'll just talk about general form separately, and then after that, we will do the conversion process. Okay guys, thank you.